Okay, so I'm Deblina Maiti, a research scholar in the Department of Mathematics, IIT Kharagpur, and I am also an NPTEL TA for the course Basic Real Analysis, and the course instructor is Professor I.K. Rana. So in the last session, we have discussed some problems from sequences and what? So in this video and the real number system, and in this session we will discuss some problems from supremum, infimum and the topology of the real line. Okay. so what is supremum of a set? So first the set has to be a non-empty set. So so supremum means, so let S be a non-empty set. Then the supremum is what? Then the supremum of S is the lowest upper bound. Then U is said to be the supremum of S if the first thing is what? U has to be an upper bound of S. U is an upper bound. And what? U is the lowest upper bound. This means what? This means if V is any upper bound, then this V will be greater equals to U. That's why U is the lowest upper bound. So this is the definition of supremum. And infimum is what? Again, the set S is non-empty. Then W is said to be the infimum of S if W is a lower bound and it is the greatest lower bound. So this means if there is any lower bound, say X, if X is any lower bound, then it has to be lesser than this W, right? This means if U is the supremum and V is any upper bound, then V lies in the right hand side of U for supremum case. U is the supremum of S. And for infimum, if W is the infimum, then it is the greatest lower bound. This means if there is any other lower bound, then it lies in the left hand side. So the X is less equals to W. Right, this is the definition of supremum and infimum. Now, the question is the existence and uniqueness. So if S is given, S is a non-empty set, then does there exist two supremum of a set S? Can you guess if it is unique or not? So the question is, if the supremum or infimum exists, if it is unique or not. So first the existence. So the existence comes from the completeness property. So the completeness, so first question is existence. And what about the uniqueness? If exist, does there two supremum or there is only one? Uniqueness. Right. So the existence comes from what? The completeness property. I have already told you the completeness property. The completeness property of R says what? Says that every non-empty subset, every non-empty subset of R for every non-empty, if it has a upper bound, then it also has a supremum. If it has an upper bound, then it right. So what? So if supremum exists or not. So if completeness property says every non-empty subset which has an upper bound also has a supremum in R. So if it is bounded, then it has supremum. So existence is done for non-empty subset. Now what about the uniqueness? So can there be two supremum of a set? So
No, ma'am.
why?
No, ma'am. Supremum is one.
You have to give
Supremum
a
is one only have upper bound.
yes, but
Then it is unique.
yes, but you have to prove it. The thing is,
Ma'am, because it is the least upper bound. So if we take two of them, then we can say that the other one is like if we take two, say u and u dash
yes,
are the
yes,
supremum, then we say that u dash is that element from which all other elements are less than or equal to. And also the same for u.
yes, yes, yes. So there is at most one supremum of a non-empty set. Why? Because if suppose there is two, so suppose u1 is supremum of S and u2 is also supremum of S, then the order property says what? If there are three possibility, either u1 less than u2, u1 equal to u2, or u1 greater than u2, right? This is the order property of real line. So these three thing is possible. Now suppose the first one, if u1 less than u2, now u2 is a supremum, right? So u2 is supremum means u2 is the lowest upper bound. So any number which is less than this number cannot be an upper bound, right? So since u2 is the supremum, u1 cannot be an upper bound, right? This is a contradiction because u1 is supremum of S also, so u1 has to be an upper bound. This is the definition of upper bound, that the supremum needs to be an upper bound and this is the lowest upper bound. So this contradicts that U2 is a supremum, right? So this is the proof. So there exists at most one supremum, because there are sets where supremum does not exist, right? Can you give an example where the supremum does not exist? So any unbounded set. So if we take 1 infinity, so there is no supremum because it is not bounded. So if we take any point, there exists a point which is larger than that point, right? So it does not have a supremum. So this now we have defined this supremum and infimum for non-empty sets, right? Now what about the empty set? So question is, what is the supremum and infimum of the empty set? Okay, can you tell me, anyone? So S is phi means what? Phi means there is no element, right? So any point of R is an upper bound. Since there is no element, any point of R is an upper bound of this S, right? So any real number is an upper bound, and same for infimum, any real number is an lower bound, right? So if any real number is the upper bound, then what is the lowest upper bound? That is the minus infinity. But infinity is not a point, so neither the supremum infimum exist. And if we say infinity is a point, then the supremum is will be minus infinity and the infimum will be plus infinity, right? So supremum and infimum does not exist. Does not exist means it is not finite. Either it is plus infinity or minus infinity. Okay. Does not exist. Okay, so now let's see some properties of this supremum. Okay. Let U is the supremum of S. So S is non-empty set. Then the first thing is what? If V is any upper bound, then U is less equals to V, right? Second is, if Z is less than this supremum, then Z is not an upper bound. Okay. The third property is, if Z is less than U, then there exists a point S set in S such that z is less than sz. Right. So what I am saying is that u is the supremum, right? So any point of s lies in this, on the left side, right? Now z is here, some z is less than u. Now I am saying is that there exists at least one point sz here such that z is less than sz. Why? Because if every point of s lies in the left hand side of this z, then z is the upper bound, z is the lowest upper bound. If there does not exist such sz in s, then z will be the lowest upper bound. So that's why there must be a point of s in between this. Yes, this sz can be u. This means the supremum may be in the set s, right? But it is not always true that the supremum belongs to the set. Okay. So I hope you understand this. And the fourth is, if epsilon greater than 0, then there exists some s epsilon such that u minus epsilon is less than epsilon. See, this 3 and 4, these two are equivalent. So 3 says what? If z is less than u, then there exists some point of sz between z and this, between this means z less than sz, and this sz can be u. So this less equals to u, right? 3 says this. Now 4 means what? For epsilon greater than 0. So to come 3 from 4, so we'll take this epsilon to be u minus z, right? So this is greater than 0, and this means there exists sz, which we will denote by this s epsilon, and z is, we have this z less than sz. So z is what? Z is u minus epsilon. So u minus epsilon is less than this sz. We will denote this by s epsilon. So this is s epsilon. So 3. So we have come 3 to 4. And from 4 to 3, this is the same thing. Right? So that's why this 3 and 4 are equivalent. So these are the properties of supremum. Alright, so let's take one problem. So you have understand till now, right? Because we will use these properties. So an upper bound u of a non-empty set S So it says what? An upper bound will be the supremum. So the upper bound u will be the supremum of S if and only if what? For every epsilon there exists a point S epsilon in S such that this happens. This u minus epsilon is less than epsilon. See, we have already proved this part, that if u is the supremum, then this happens, right? We have already seen this. So the necessary, so if u is the supremum, the upper bound is the supremum, then this follows. We have already discussed it. So let epsilon greater than 0. So it means what? U minus epsilon is less than u. Right? So u is the supremum. So u minus epsilon cannot be an upper bound. So u minus epsilon is not an upper bound. So this means what? Since this is not an upper bound, so there exists a point which is greater than this point, right? So there exists some s epsilon belongs to, so u is here, u epsilon is, u minus epsilon is here. So u minus epsilon is not an upper bound. So there must be some s epsilon belongs to s such that u minus epsilon is less than that epsilon, right? So the first part is proved. Now for the converse part, so u is an upper bound and u satisfies this property, right? So u is an upper bound and u satisfies this property. So we have to show that u is the supremum. So supremum means what? So to show supremum of s is u, right? Supremum means what? If there is any other upper bound, then it has to be greater equals to this u, right? So let v be any other upper bound. Upper bound of s, right? So now put okay. We can show that if v any other upper bound is greater than u, then it is the lowest upper bound. Also we can prove that if v is any number which is less than u, then that cannot be an upper bound, right? Also we can prove like this. So let v is less than u, then if we show that v cannot be an upper bound, then u is the lowest upper bound, right? So let v is less than u. So then take epsilon to be v minus u, sorry, u minus v. So it is greater than 0. Now we'll use this property. So epsilon greater than 0, so there exists some s epsilon by the hypothesis belongs to s such that u minus epsilon is less than this s epsilon. So this means what? U minus epsilon is what? V. So V is less than S epsilon. Right. So any point which is less than this U, this is bounded by a point of S. Right. So this S belongs to S. This is bounded. So this means V is here and U is here. So any point which is less than this U, there is a point S epsilon between this, which belongs to S. So V cannot be an upper bound because there is a point of S which is greater than this V, right? So V is not an upper bound of S, right? So any point which is less than V is not an upper bound, and U is a upper bound. So that's why also U is an upper bound. So this will imply U is the lowest upper bound. U equals to supremum of S, right? So this is proof. You understand it, right? Okay, so if there is no doubt, I'll go to the next question. Okay, so find the supremum the following sets. So first one is okay. So everyone try this question. So what about the first one? So S1 is what? All those x such that x square minus 3x plus 2 less than 0. So this is what? This is will be x minus 2, x minus 1, right? So this means what? This is less than 0 means either one of them is positive and one of them is negative. So 0 and so this means x greater than 2 and x less than 1. So I'm doing it right, or you please try this question. So this is 1, 2. So if it lies between these two, then x minus 1 will be positive and x minus 2 will be negative, right? And if it lies, if x is greater than 2, then both of them will be positive. Okay, so this is not possible, this case not possible. So there is another case which says x minus 2 less than 0 and x minus 1 greater than 0, right? So then it will imply x less than 2 and x greater than 1. So this implies 1 less than x less than 2. So S1 is actually this number, this 1, 2, this interval 1, 2, right? So what is the supremum of this set?
2.
2, and supremum, here the supremum does not belongs to the set, right? So supremum of S1 is 2, right? Similarly, find the next one. So
That to supremum is 2.
so S2 is what? Okay, I will check. X square minus x minus 2 will be less equals to 0, right? So this is This means this is x minus 2, x plus 1. So it will give the set, what? It will give the set, it will lie here, right? So S is the set what? Minus infinity to 1, and since it is equal to 0, so 1 will be there. Union 2 to infinity, right? So here the supremum does not exist.
Shouldn't the set be from -1 to 2
Why?
for negative part?
Because it lies between minus, oh sorry, this is minus 1. This is minus 1 to 2, then this will be positive. Okay. Yes, I think it will be.
Yes, ma'am, this one will be positive. X plus 1 and x minus 2 will be negative.
Yes, yes. So the point will lie here, right? The equation. So x plus 1 greater than 0 implies x greater than minus 1. Yes, so this will be the same thing. Okay. So again, so the supremum of S2 will be 2. And 3 is same. C is what? C is minus 1 to 1, right? So if we change the inequality in S2, this if this minus less equals to 0, if we take greater equals to 0, then it will be that minus infinity to minus 1 and 2 to infinity. Then for that set there will be no supremum, right?
Yes, ma'am.
Okay, so S3 is again x squared less than 1. So this is minus 1 to 1 and the supremum is 1, right? Supremum is 3 is 1. Okay, so let's go to the next question. So suppose S is a non-empty subset of R such that supremum of S equals to infimum of S. Then what can we say about the set S? Then say about the set S, right? So can you give an example for which the supremum of this set is infimum of the set? First we'll see an example. So can anyone try?
A single element in the set would
Yes.
be that way.
Yes. If it is a singleton set, yes, yes. If A is singleton set, suppose A belongs to R, then supremum and infimum will be both A. Supremum of S, infimum of S is A. Same. Now what about if S is not singleton, right? Does there exist any set which is not a singleton and this property is satisfied? So so if possible, let there are two numbers in S, right? S satisfies this property. uh, Two distinct numbers v1 v2 belongs to S and supremum of S equals to infimum of S. Okay, S satisfies this property, supremum of S equals to infimum of S, and I am saying that S is not singleton. So there are at least two distinct point. There are at least two distinct points v1 v2 in S, right? Now by the ordered property, either v1 less than v2 or v1 greater than v2, right? Since they are distinct, there is no possibility of v1 equal to v2, right? So suppose, so without loss of generality we say v1 less than v2 without loss of generality, right? This is the same thing, so I am choosing v1 less than v2. Now infimum of this set S means what? It is the greatest lower bound. First it is a lower bound, right? So this is less equals to v1, right? Because any number of this S is greater than this infimum, right? Now v1 is less than v2 and v2 will be less than supremum of S, right? Because supremum is an upper bound of the set S. So this implies what? This implies supremum of infimum of S is strictly less than supremum of S, right? So we have, so this contradicts our hypothesis, right? So this contradicts that supremum of S equals to infimum of S, right? So this means S has to be a singleton set, right? So this implies S has to be a singleton set. For singleton set, this is clear, but we have to prove singleton set is the only possibility, right? That's why we have proved this. Okay, I hope you have understand this, right? Okay, so let's go to the next problem. So question number 4. If S now I'm saying if a set S contains one of its upper bounds, then that upper bound will be the supremum of the set. Then this upper bound is the supremum, right? So we prove this. So let U is the upper bound which belongs to this set. Let U be the upper bound of S such that U belongs to S. Right. Now we have to prove what? Supremum of this S is U. Right. We need to prove this. So if we take any other upper bound, let V be any other upper bound. Upper bound of S. Right. Now can you try from here? So U is an upper bound, U belongs to S, and V is any other upper bound, right? So V is any other upper bound means what? This means S less equals to V for all S belongs to this S, right? Now U belongs to this S. So U also satisfies this property. This implies U less equals to V, right? So this means what? U less equals to V means if V is U is less than any other upper bound of S. So U is the lowest upper bound, right? So this implies U is the supremum of S. Because U is the lowest upper bound, any upper bound is greater than this U, right? So U is supremum of this way. This is a one line proof. Okay. So if there is any doubt, you can ask. So I think is 4. So S4 is this set and we need to find supremum and infimum of this set, right? So try everyone. This is simple one. So let AN is right. So A2n is what? 1 minus. So this is 1 by 2n for n greater equals to 1. And A2n minus 1 is what? So see, if this is suppose 1, right? Now A2n is what? 1 minus 1 by 2n. So A2n lies somewhere here. 1 minus 1 by 2n. And A2n plus 1 minus 1 is what? 1 plus 1 by 2n minus 1. Right. Now if n increases, this A2n minus 1 decreases. So it goes close to 1. And here this A2n goes to close to 1. Right. So if n increases, they goes close to 1. So the farthest point is what? So the farthest point is what? A1, right? Because if you increase it, it will go close to 1. Right? So the farthest from in this right side is A1 and the farthest point in the left side is what? A2, right? Because if we increase n, then it will be here. So A2 is what? A2 is 1 minus half and A1 is what? A1 is 2, right? So this means half A2 equals to what? A minus half. This is less than Sn. less equals to a1, which is 2. So all the numbers this an lies between half and 2. So clearly 2 is an upper bound, right? And see that 2 also belongs to the set S4, because 2 is what? 2 is an upper bound and 2 equals to a2, which belongs to the set S4. So from the previous problem we see that what? If the upper bound belongs to the set, then it is the supremum, right? So 2 belongs to the set S4, so 2 is the supremum. So supremum of S4 is 2. And similarly, half is a lower bound and half belongs to the set. So infimum will be half, right? Okay. So take another question. So let A and B be bounded subsets of R. Okay. Then show that okay, then A union B is also a bounded subset, also bounded, right? Now show that supremum of this A union B is maximum of these two, supremum of A and supremum of B. Okay, we need to show that. So it is clear, right? If A, B are bounded, then A union B is also bounded. So it is bounded by the maximum of the bound of these two, A and B, right? So now, so we will prove this less equals to this, left hand side is less equals to the right hand side, and the right hand side is less equals to this number. Then this is equal, right? So first we see that A is contained in A union B, right? Then what is the supremum of A, relation between supremum of A and supremum of this A union B? So supremum of A less equals to supremum of A union B, right? This is clear because A union B is the bigger set containing A, right? Also B is contained in A union B, so supremum of this B is less equals to supremum of this A union B, right? So the maximum of this supremum of A and supremum of B will be less equals to this number, because what? Maximum of this supremum A, supremum of B will be either supremum A or supremum of B, and they are less equals to this supremum of A plus B. So maximum of this less equals to this. So one direction is proved, right? Now we need to check the other one. So for the converse part, let X belongs to A union B, right? So this means what? This means either X belongs to A or X belongs to B, right? So X belongs to A means what? This means X less equals to supremum of A And this one means what? Clear? Because supremum is an upper bound, so x is less equals to supremum of A, or x is less equals to supremum of B, right? So this means x is less equals to maximum of this supremum of A and supremum of B, right? Okay, so x is any number from this A union B, and this x is less than this number, this maximum of this supremum of A, supremum of B. So this means what? This means this number, this maximum of these two numbers is an upper bound of A union B, right? Because this x is any number from A union B. So this means this maximum of these two numbers is an upper bound of the set A union B, right? So this is an upper bound, and supremum of A union B is the lowest upper bound. So this implies what? This implies supremum of A union B is less equal to maximum of this, right? Because supremum is what? Supremum of a set is the lowest upper bound. So this supremum has to be less equals to this upper bound maximum of these two numbers. So we have the other direction. So from these two we get this equality equal to maximum of this, right? So this is proved. Okay, now we'll discuss the topology of the real line. Okay. So first, what is the topology means? The topology is a general concept. Okay, so this is not only defined for the real line, it is defined for Rn, any metric space, right? So a topology is what? A topology tau of a set X is a collection of subsets of X that satisfies three axioms. So the first one is what? The boundary condition, that is phi, the null set and the whole set belongs to the set tau. Second condition is what? The arbitrary union of subsets of this tau belongs to the set. So the union of arbitrary collection of the set tau must belong to tau. And the third one is what? The finite intersection will also be on tau. So section of finite of any finite collection of the sets, okay, the sets in tau must belong to tau. So topology is this one. Topology is a collection of subset of x. So then we say this tau x is a topological space. Right? This x is not a subset of real line here. This is a general definition. Okay. Now in case of the real line in R, we'll see that this tau is nothing but the collection of all the open intervals, because the open set satisfies these three property. This phi and the whole set R is open. The union of arbitrary collection of open set is also open, and intersection of finite collection of open set is also open. So in R, tau is the collection of all the open intervals. Right? This we will see next. So now we will define this open set neighborhood. And now to define the open set, we first need the definition of a neighborhood. Right? So now neighborhood means what? Some points which are around that point, say x. Right? Now around a point means what? We need to measure the distance, right? So this is far from that point or this is close to that point. So we need a distance to measure the measure it is closer or it is far from the point, right? So first we need to define the distance. So in R, the Euclidean distance is what? Dxy denotes the distance, suppose distance between x and y, right? So in R, this dxy, the distance between x and y, is defined by this mod of x minus y, right? Now an epsilon neighborhood of a point x means what? All the points which is epsilon distant away from this x, right? This means what? All those x, oh sorry, we have this let's take this point A. So all those point x belongs to R which is epsilon distant away from this A. So this means distance between A and x is less than epsilon, right? So this is a epsilon neighborhood of a point. Means this, suppose this is A. So all the point which are epsilon distant away. Now we know the function dxa. So here dxa is what? Mod of x minus a less than epsilon. Now mod of x minus a means what? This means a minus epsilon less than x less than a plus epsilon. So this is nothing but the interval a minus epsilon to a plus epsilon. So in R, an epsilon neighborhood means of a point means this open interval a minus epsilon to a plus epsilon. Now if we go to R2, so in R2, so a point is what? Is a tuple. So suppose this a1 a2 belongs to R2. So epsilon neighborhood of this point a1 a2 is what? All those xy's belongs to R2 such that the distance function, the d of xy, here the point is a1 a2 and the other point is xy, this is less than epsilon, right? Now what is the distance function here? So I'll write this here. So d of this x1 y1 x1 x2 and y1 y2, this distance function is what? This is the Euclidean distance x1 minus y1 whole square plus x2 minus y2 whole square, right? This is the distance function is in R2. So with respect to this distance function, we get all those xy such that root over of x minus a1 square plus y minus a2 square is less than epsilon. So this implies all those xy such that so this equation is a equation of a circle, right? So in R2 means a plane, right? So there is some point a1 a2. Now epsilon neighborhood of this point means what? This is a disk, because this is less than epsilon means all the points inside this radius is what? Radius is epsilon. So the epsilon neighborhood of a point a1 a2 here is a open disk, because this is less than epsilon square, open disk with center a1 a2 and radius epsilon, right? So this is in R2 and this is R. So we'll briefly discuss this, and when the metric space and all these things come, we'll discuss this in general metric space R2 Rn. You can increase n, right? After R3 we cannot visualize the ball or this neighborhoods, right? So in this session we will discuss only about R. So what we have defined the epsilon neighborhood of the real line. So we'll only discuss about the topology of the real line. So what about the general neighborhood? Epsilon neighborhood is what? This interval. So a general neighborhood means, so neighborhood of a point. Now I am going to discuss everything in R, right? So a point, a neighborhood of a point, say A belongs to R, is any set that contains an epsilon neighborhood, say n epsilon A. See here, this n epsilon A is what? This A minus epsilon to A plus epsilon, right? So any neighborhood means what? This is not symmetric. Epsilon neighborhood is always symmetric. If we take A, then this is A minus epsilon, A plus epsilon. So any neighborhood is means a neighborhood, suppose this one, this is V. So any neighborhood which contains an epsilon neighborhood. So this is A minus epsilon, A plus epsilon, and this n epsilon A is contained in this V. So this V is a general neighborhood of a point, right? Now we'll define the open set. A open set means a set G of R is called an open set if for each point there exists a neighborhood which is totally contained in this G. If for each x belongs to G, there exists a neighborhood V, neighborhood say N, such that nx which is totally contained in G. See, this nx may not be an epsilon. Nx may not be an epsilon neighborhood, but nx contains some epsilon neighborhood. A general neighborhood means it contains some epsilon neighborhood. So open set means for each point we will find a neighborhood of this x which is totally contained in the set G, right? And closed set is what? Now we are defining a closed set from the open set. This means a set f of R is closed if f complement is open. So we have defined closed set from closed set from the definition of open set. We are saying f is closed if f complement is open, right? Now from the definition, now what do we need to show a set is open? So G is open. To show G is open, what do we need to show? So we need to show that for each x in G there exists some epsilon neighborhood depending on this x, epsilon neighborhood, that is some x minus epsilon x and x plus epsilon x, which is totally contained in G, right? So to show G is open, we need to show this one. Now to show f is closed, what do we need to show? So to show f is closed, what is needed to be shown? So f is closed means what? So this implies what? From the definition, f complement is open, right? Now f complement is open means what? From the definition, for each y belongs to f complement, there exists some epsilon y neighborhood, that is say y minus epsilon y and y plus epsilon y, which is completely contained in this f complement, right? So this means for any each point y does not belongs to f, has an epsilon y neighborhood, this y minus epsilon to y plus epsilon, which is contained in f complement. This means f intersection this interval is phi, right? This is totally contained in f complement. This means this does not contain any point of f, right? So to show f is closed, we need to show this. If a point which does not belongs to f, then there exists a neighborhood of this type of such that this does not contain any point of f, right? So this is needed to be shown. Now we'll see some examples. So first one is phi. So phi is open, right? Because there is no point to be checked, so it is trivial, so phi is open. Now second thing is the whole set R. What about this R? So R is open or not? R is open because if we take any x and take epsilon to be 1, we have to this means what? If for each x in that set we have to find epsilon neighborhood which is totally contained in that set. So if we take epsilon to be 1, this x minus epsilon to x plus epsilon, this is contained in R. We can take epsilon to be any 1, 2, 3, anything like that. So everything is contained in this R. So for each x, for each x belongs to R, this happens. We have found a neighborhood which is totally contained in the set R. So this means R is open, right? So what about the set this AB, this interval AB? So we know that this is an open set, but by the definition, so we have to find for any x, suppose x belongs to this AB, then we have to find a neighborhood of this x which is completely, so let's take A. So you have to find a neighborhood, say nx, which is completely contained in this A. So what is the neighborhood? So can anyone guess? So x is here. So we have to choose that epsilon. So what we choose this epsilon such that this neighborhood lies in this A. So can guess. So there is our x. This is A and B. So see what is this distance? This is what? This is x minus A, right? And this distance is what? This is B minus x, right? Because here this A is less than B. Now what will we choose? We'll choose minimum of these two, because the minimum of these two, if we take epsilon to be minimum of these two set, this mod x minus A and B minus x, right? Then if this is less than, so the epsilon neighborhood of this x is what? This epsilon neighborhood of x means this one. So this lies between AB, right? So so x is where? Suppose this is A and this is B. So this is the minimum one, x minus A. So epsilon neighborhood of this means from this one to this. So this is x minus epsilon, this is x plus epsilon, right? So then epsilon neighborhood of x is completely contained in this AB, right? So this implies AB is open. For any AB. Now, what about the set this A, closed A and open B? Is this one open? This is not an open set because for the point this A will be a problematic point. Why? Because any epsilon neighborhood of this point A contains some point which does not belongs to this set AB, right? Because our A is here and this is B. So if we take any neighborhood of epsilon neighborhood, so this will be epsilon, this is A plus epsilon. So the points on the left hand side of this A does not belongs to the set this S, right? So that is why this set AB is not open, right? So what about the set N, set of all natural numbers? So this is also not open because they are isolated points. If we take epsilon to be half, then epsilon neighborhood of any of this point, any of this x, so this epsilon neighborhood of x is what? This x minus half, x plus half, right? Where x belongs to this n. So this does not belongs to n. So there are points which is rational, irrational, but they does not belongs to this epsilon neighborhood, is not completely contained in this n, because there are rational numbers, irrational numbers, right? That is why n is not open. Okay. And q is also not open because any neighborhood.
Ma'am, are we taking the domain as real numbers?
What?
Are we taking the domain as real number for all these questions?
No, not real numbers. We are saying an epsilon neighborhood of the set. Epsilon neighborhood of this point is what? Epsilon neighborhood of this point is this set, this 2 minus epsilon to 2 plus epsilon, suppose. So this total interval, this is the epsilon neighborhood, and this interval is not contained in n.
Okay, ma'am, I understand.
So that's why this is not an open set. Similarly for q, if we take any point from q and the epsilon neighborhood of x is what? This x minus epsilon to x plus epsilon, which will contain some irrational numbers. So q is also not open. Right? Then now what about the closed set? Right? So we have phi is open, right? So phi is open means phi complement is closed, right? So phi complement is what? R. So R is closed. Now R is open. So this will imply phi is closed, right? Now AB is open. So complement of AB looks like what? This set is, so this is a closed set, right? Also this set AB, closed AB, this is also closed. Why? Because AB means, AB is what? AB is minus infinity to A union B to infinity, right? So this is union of two open set, that's why it is open. Okay, we'll see the properties of the open sets and the closed set. And okay, so what about the set N? It is closed or open? it is not open, so it is closed or not. Okay, I will describe the properties and then you can answer this question. So properties of open set. So the first one is what? The union of arbitrary collection of yes, tell me.
Ma'am, how have you written this A to B interval closed is equivalent to minus infinity to A
Oh,
union B
sorry,
to?
this is the complement. Yes, yes. Thank you. The complement of this AB is minus infinity to A union B to infinity. Now, since the
Okay.
arbitrary union of the open set is open, so this complement is open. That's why the closed interval AB is closed. That's what.
Okay, thank you.
Okay, thank you. So so this is union of two open set. So this will imply AB complement is open. This means AB is closed. Right. Now this is complete. Okay. Now the properties is the union of an arbitrary collection of open subsets in R is open. Second one is that the finite intersection of subsets of open, and the third one is a subset of R is open if and only if it is the union of countably disjoint okay, this is the properties of open set. So first one is the union of arbitrary collection of open subsets in R is open. Finite intersection of the open subsets in R is open, and the last is the characterization of the open set. A subset of R is open if and only if it is the union of countably many disjoint open intervals in R, like 1 2 union 3 4, like this is open. So this is a characterization of open set. Now you can check any general real analysis book for the proof of these properties, right? Now I'll give properties of the closed set. So here the arbitrary union was open, but here the arbitrary intersection is closed. So the intersection of an arbitrary collection closed sets in R is closed. And second one is what? Finite union of closed set is closed. Collection of, okay, I have collection of open subset. Right. So for open, arbitrary union of open set is open and finite intersection of open set is open, and for the closed set the converse, like the arbitrary intersection of closed set is closed and finite union of open closed set is open. Now why this is, what about if we take the arbitrary union of closed set? So we have to give an example to discuss this situation, that arbitrary intersection of closed set is not closed, and also the arbitrary union of closed set is not closed, and arbitrary, okay, I'll give the example. Then say this in is, suppose 1 minus into. Now we'll see that if we take the intersection, so intersection of in is what? Intersection of in is, you tell me.
1.
Yes. So arbitrary intersection here, this is not finite, right? So this is infinite intersection of this in. So all this in is open, but the intersection, the arbitrary intersection of this in is what? A singleton set. So this is closed set, right? So that's why arbitrary intersection of open set is not open, and arbitrary union of closed set is not closed. So we have to give an example. So let's take Jn to be closed set. We have to take this one. Right. So now take union of this Jn. So here this was 1 and 1 minus 1 by n, and this is 1 plus 1 by n. So when n increases, this open intervals are decreasing, they are squeezing, so they are the nested intervals like this, right? But here the interval is like, this is minus 1, this is 1, and 1 minus minus 1, so there is somewhere minus 1 plus 1 by n, and this is 1 minus 1 by n, right? So these intervals, these jn are expanding, right? When we take n increases n, then this jn they are increasing, so they will go to what? They will fill up this minus 1 to 1, right? When n goes to infinity, then this will go to minus 1. This minus 1 plus 1 by n. And this 1 minus 1 by n will go to the 1, right? But it can never achieve this minus 1 or 1, right? It will be close to minus 1. but there is no n for which this minus 1 plus 1 by n equals to minus n, because this means what? This means n is infinity, but infinity is not a number. So this is the open minus 1 to 1, right? So union of these closed intervals, arbitrary union of this closed interval is open. So they are closed, but the arbitrary union is open, right? So these are the counter examples, right? Okay. Now,
Excuse me, ma'am, like what the properties we have written above, so it means they are not going to satisfy always, no? Above we have written the properties, no?
yes,
So
their properties means if it is open set, then these already holds. They are true. Counter example is for I have written what here. I have written that the intersection of finite collection of open set is open. So why doesn't we take the infinite collection? Because union of arbitrary collection is open, but why not the arbitrary intersection of the open set? That's why I give counter example, right? And similar case for closed set. I have written this arbitrary intersection of closed set is closed, right? And when we are taking the union, there is finite collection of union, a finite union of collection of closed subset is closed. Why not the arbitrary union? Why not? Because there are examples like this and this for which this arbitrary collection we cannot take, right? And these properties are proved. They are already proved in books. You can see any books because they are the fundamental properties. So they are available in any real analysis book, right? Or if you have watched the video lectures, I think sir have already proved these properties. So if you have any doubt now, then ask. Okay, so I think no one has a doubt. So here we have defined the closed set like what? Closed set is a complement of a open set, right? But there are definition in some books, but different definition of closed set, right? So there are other definition like F is closed if um, if xn is a if xn is a convergent sequence in f wait f is closed if xn is a convergent sequence in f such that limit of this xn belongs to f, right? This is some other definition of closed set, right? This is also a definition in some book. So we have defined two definition of closed set. So this means that two definition are equivalent, right? Because every definition is equivalent. So this means the characterization of closed set so this means if subset of R, then the following are equivalent. the following two definition. So the first one is what? F is closed with the definition that F complement is open, right? And the second one is what? If Xn is any convergence sequence in F, then limit Xn belongs to F, right? So you have to prove if 1 happens, then 2 will be satisfied, and 2 happens, then 1 will be satisfied, right? So first we will go from 1 to 2, right? So F is closed. F is closed means what? F is closed, right? So this means what? This means F complement is open by the definition we have provided, right? So F complement is closed. Now you have to prove. And so F is closed and Xn is a convergent sequence in F, right? Now to prove limit of Xn belongs to this F, right? We have to prove this one. So if not, we will prove this by contradiction. So if not, let X, the limit, does not belongs to F, right? We'll prove this by contradiction. So we suppose this does not belongs to F. So this does not belongs to F means what? This belongs to the complement, F complement, right? And now our F complement is open since F is closed. So this means there exists a neighborhood, there exists epsilon greater than 0 such that this neighborhood x minus epsilon to x plus epsilon is contained in this F complement, right? Okay, so this means what? Also, x is what? X is the limit xn, right? Now from the definition of limit, x is the limit means for any epsilon greater than 0, we'll take the same epsilon. For any epsilon greater than 0, there exists a natural number n such that what? This mod of xn minus x is less than epsilon for all n greater equals to n, right? From the definition of limit. So what is this mod of xn plus? This means what? This means xn belongs to this x minus epsilon to x plus epsilon for all n greater equals to n, right? This is same thing, mod of xn minus x. So what we have found is that xn belongs to this interval for all n greater equals to n, and this interval is contained in what? We have found that this interval is contained in F complement, right? So this means what? Xn belongs to F complement for all n greater equals to n. This means all the xn does not belongs to F for all n. After this n, capital N, all the xn's does not belongs to F, right? So this is a contradiction because we have chosen this xn is a convergent sequence in F, means all the xn belongs to F. So this is a contradiction. So this contradicts that xn belongs to F for all n, right? So this one is proved 1 to 2, right? Now we have to prove 2 to 1. This means xn is convergence sequence and limit xn belongs to f. Then we have to show that f is closed. Okay. 2, 2, 1. So suppose, so if not, suppose f is not closed, right? So we are proving by contradiction. So f is not closed means what? F complement is not open. Right. Now F complement is not open means what? The negation of open set was what? We have written here. See, this is the closed set. So F complement is open means this, there exists an epsilon neighborhood such that it does not contain any point of f, right? We'll use this thing. So we have that f complement is not open. So for openness we have that for each point x there exists a neighborhood which is totally contained in this f complement, right? So for open, I'm writing the definition again. If G is open, then for each x in G, there exists epsilon neighborhood of x such that there exists epsilon such that this epsilon neighborhood of x is totally contained in G, right? This was the condition for openness. Now it is not open means what? For each x mean there exists, so there exists some y not suppose belongs to this f complement such that, so here was that there exists epsilon for which this neighborhood is totally contained in G, right? Now for the negation, for every epsilon, that means for every neighborhood, if we take every neighborhood of this point y naught, we'll find some points which does not belongs to this G, right? This is the negation. Here what was that? Here was for each x, this is valid, so this means there exist, the negation will be there exists a point y naught, and there was epsilon, there exists an epsilon, right? So here for every neighborhood, for every, if we take every neighborhood of this y naught, we'll see that this is not totally contained in this G. This means what? There are some points which are not in G, which are in complement of that G, right? So this means if we there exists y naught in f complement such that for every neighborhood, every epsilon neighborhood of this y naught, say n epsilon y naught is not totally contained in f complement. This means what? This means there are points, say y epsilon such that y epsilon belongs to this n epsilon y naught and y epsilon does not belongs to f complement, right? So this means what? So this means there exists y naught belongs to f complement such that mod of this n epsilon y naught means this line y epsilon belongs to this means y epsilon minus y naught is less than epsilon, and this y epsilon belongs to f. This belongs to f complement. This means y epsilon belongs to f, right? Now see, we have to find that this 2 we'll use, right? So we have to find a sequence, convergence sequence. We have to form this sequence. So from here we'll take epsilon to be 1 by n, right? Now if we take epsilon to be 1 by n, this means what? This means y naught minus this y epsilon less than 1 by n, right? This is 1 by n. So we have formed a sequence, this say yn. So this sequence yn is now what? This implies what? For this implies yn is convergent, right? Because if n tends to infinity, this yn goes close to y naught, right? So yn is convergent, and limit yn is what? Limit yn is y naught. So by 2 was what? If xn is a convergent sequence in f, then limit xn belongs to f, right? So all this y epsilon belongs to f. So this yn is a convergent sequence in f, and limit yn is y naught belongs to f by 2, right? So y naught belongs to f. But what we have in the process, see, in this line we have told that this y naught belongs to f complement, right? We have taken y naught belongs to f complement. So this is a contradiction, right? So this is a contradiction. This means f is closed, because we have taken f is not closed. So by contradiction, f is closed. So the two definition, that if f is closed means f complement is open, and the sequential criteria, that if xn is any convergent sequence, the limit belongs to the set f, then f is closed. So these two definitions are equivalent, right? So okay, I will stop here, and the next day I will discuss the problems from this open set and closed set. Okay?
Excuse me, ma'am.
Yes.
Ma'am, I have one more class, group theory class also I've taken, and real analysis also. Actually, real analysis I've taken to understand the language of mathematics, like how to go about the concepts and how to write this. So real analysis is also important for me, and group theory also I want to go through it. But there is a clash in both the classes, on the same day it is there. So can it be on Wednesday, ma'am? Next time, like today, I think it is Tuesday.
Yes.
So
No,
can
no,
it be scheduled on Wednesday?
No, actually this is already been set up by the NPTEL.
Okay. So actually, I have to drop one,
Because there
I
is
have to drop
another
one of the
problem
course.
solving session, right, in Saturday. You can take, you can attend that class.
Okay, so, there are two instructors.
Two TAs, yes. So there are two problem solving sessions. One is, I think, in Saturday, and one is Tuesday. So you can attend that course.
Okay, ma'am. Thank you, ma'am.
Okay, so you may leave now. So we'll discuss these problems in the next week. Right?
Yes, but I have one question.
Okay.
Ma'am, do we have these sessions, like it was this week 3 session or a week 2 session
This
tutorial?
is week 2 session.
Okay, ma'am. Thank you.
Okay. Thank you.
Okay, good night,
Ma'am,
ma'am.
can I get this class notes as a PDF?
What?
Can I get this notes as a
Yes, yes, I
PDF?
will upload this note in the Google Drive. I have shared the link of the Google Drive, right? In the Excel sheet. There are YouTube link and one the Drive link. I will upload it that here. Right? You can check.
Okay, ma'am.
Okay? Okay, thank you.